Guys, welcome again to our virtual practical class, and as you can see there, we have some explanations that the procedure for the practical 10, and as you can see that you are provided with an acid HCl, acid W, whose concentration is unknown. You are required to standardize it using a standard sodium carbonate solution, which is 0.5 molar, and the following is the procedure. Using a clean pipette exactly 25 cubic centimeters of the sodium carbonate solution into a clean conical flask, 250 conical flask, and add 2 to 3 drops of methyl orange indicator, and then fill up the burette with an acid W. Titrate the acid W against sodium carbonate solution until the color changes to pink. Repeat the experiment in order to obtain 2 concordite titer. Record the results in the table below, of which we have done. We have seen there, we have found out that the average volume in that, as per that table is concerned, we have found it to be 19.3. And then from there, we have calculated the number of moles of sodium carbonate used, which is sodium carbonate plus 2 hydrochloric, sodium carbonate plus hydrochloric acid. On the product side, we are getting sodium chloride and carbon dioxide and also water, which we have also indicated in their states that water is liquid, gas, carbon dioxide, and the sodium chloride aqueous. Also HCl is supposed to be an aqueous, and sodium carbonate also aqueous, of which we are supposed also to indicate. Then we went to an extent of calculating the number of moles of sodium carbonate used, of which that we compared the mole ratio, which was 1:2, and the molarity we were only given for 0.5 of sodium carbonate, and on the other side we just equated it to be X. So now in this case we went to an extent and compared 1,000 cubic centimeters of sodium carbonate, it had 0.5. What about for 25? So we just cross multiplied and found out that the answer to be 0.0125 moles that were present in sodium carbonate in 19.3 cubic centimeters, right? Calculate the number of moles used. Calculate the number of moles of acid in the volume. Calculate the number of moles of acid in the volume used. So we just went to an extent by getting the number of moles by comparing the mole ratio between sodium carbonate, as you can see up there, of sodium carbonate and hydrochloric acid, and then we found out that we knew the number of moles of sodium carbonate to be 0.0125 moles. Then the number of the number of moles of hydrochloric acid in 19.3, it was supposed to be 2 times 0.125. Then we got our answer to be 0.025 moles. Then we went further and also calculated the molarity of the acid, which we asked ourselves 0.025. We found to be 0.025 moles were present in 19.3 cubic centimeters of the average volume of the acid that was used in the burette. So what about in 1,000? So now we cross multiplied 0.025 moles times 1,000, then over 9.3. So we found to be 1.2 molar. Last but not least, we went to an extent of calculating the concentration of grams per liter. So now I just want to make a slight correction here because of. So we went to an extent of asking ourselves if the molarity here, if the molarity is equal to mass in grams per liter divided by the RFM, we found out that molarity times RFM. So we just we multiplied both sides by RFM to make the molarity to be the subject of the formula. So we went to an extent by equating 1.2, which is our molarity that was here, and then we multiplied by we multiply. It is supposed to be the RFM. The RFM in this case, because of the mole ratio here, 1:2. Therefore, we are supposed to multiply everything by 2 like that, so that we can get here. We can get here 35 point what? The relative atomic mass of commodity says 35.5. Then here we multiply it by 2. Then we also multiply by 2, so that we get 2 here, and then here we are going to get something to do with it. We got, because 35 times 2, that is 70. 71, right? Yes. Isn't it? Yes. So we just find to be 71.0, right? Yes. So if we add everything now, we are going to get what? 73.0, right? Yes. So we just take this 73.0 and say, therefore, 1.2 times 73.0 is equals to. So we just take our calculator very fast. It's going to be. Let us just get 1.2 times 73.0 is going to be
87.6.
87.6, right?
Yes, grams per
liter. For those short remarks, we have come to the end of this discussion. Otherwise, thank you in advance, and make a follow-up, subscribe, and also correct us. We shall appreciate so much. Thank you, and bye-bye.